here's a healthy challenge for you. So we've got linear equations, and we've learned that a linear equation is written in the form y equals mx plus b, all right? And I want to figure out what a linear equation would match up to this blue line that I see here on my screen. So I want to think, what are some things that I know already about y equals mx plus b? Well, y equals mx plus b, the b, we know, we've come to realize that it symbolizes the y-intercept. If I click on this function, I see that the y-intercept is at 0, 5. So I am going to fill in this b value with a 5. And now really I just have to determine my slope, the m value. So I take a look, and it's good to start with the y-intercept, and I think, well, how do I get to the next point? And it appears as though my point here at 1 has a decimal or a fraction. So I want to find the next integer point, integer, meaning that both the x and the y are integers. The next one that I find is actually 3, 0. So if I focus on these 2 points and I say, how do I go from A to B? Then I would have to go down 5 units and over 3 units, which makes my slope down 5 over 3. And you see that when I graph that, negative 5/3 x plus 5, I graph the same line. Now, challenge number 2. What line would contain the points 5, negative 10, and negative 3, negative 10? So a cool feature right here with Desmos is that you can graph both of these points. So I'm going to say 5, negative 10, and I'm going to label it point A. And I can actually put another one by putting a comma. Well, let's see, I can put the point negative 3, negative 10. And let's see, maybe I have to separate them with a comma. There we go. Okay, and I am actually not going to label them because it wants to give the same label. So I don't see these, but that's because of my window. So if I zoom out a little bit, I can find that both of these right down here. They're right down here. So I'm thinking, what line could I draw to connect those 2 points? And when you're envisioning connecting those, I hope that you see that it would have a y-intercept at negative 10. So if we're looking at y equals mx plus b, y equals mx plus b, well then we definitely know that our y-intercept would be negative 10. Right? And then we think of our slope. So to go from one point, from the left point to the right point, how much do I rise and how much do I run? So I don't rise any at all, right? Because the y value doesn't change. But my run is, well, from negative 3 to positive 5, I ran 8. So that is really, if we're looking at slope, rise is 0, run is 8, so 0 over 8. In other words, 0 divided by 8 is 0. So we're going to go with y equals 0x minus 10. So that graphs it correctly. Now, if you have 0x, you don't really need it, which means that this equation is actually can be written as y equals negative 10. That is the trick with a horizontal line. You don't really, you have a slope of 0 for a horizontal line, so that's y equals negative 10. For a vertical line, you actually would have an undefined slope, so you actually don't call that a function at all because it fails the vertical line test. That would be, for example, x equals negative 10 if you have a vertical line. All right, but let's move on to one that is not vertically or horizontally aligned. So what if I had the points negative 2, 3, and I'm just going to put them right here. So negative 2, comma 3, and then negative 14, comma negative 5. So negative 14, comma negative 5. So the first thing I want to do, whether it's on paper or with Desmos, is I want to graph those. I want to see what that looks like. So let's turn these points on. And here they are. All right. So they're over here towards the second and third quadrant. And it looks like a positive slope. And I'm unsure of where it's going to hit the y-axis. It looks like maybe somewhere between 4 and 6, something like that. So we want to find the equation. So let's do a little bit of work with average rate of change first. And so basically by doing change in y over change in x, I can find that the slope is 2/3. Now, to find my y-intercept, I could substitute an xy, like a double evaluation, to find b, and I can check this equation,